Welcome back. The other topic that we will be looking at in this section is rational inequalities. So a rational inequality is what we call any situation that can be written in one of these four forms where we are able to write a rational function on one side of an inequality and zero on the other. So getting a rational function that is a polynomial over a polynomial on one side of our inequality and zero on the other is the situation. So here we see a rational function on the left and zero on the right, and an inequality sign. We are dealing with a classic rational inequality. And I would like to first look at solving this by graphing. So I'm going to figure out what the graph of this polynomial looks like. This rational function, this ratio of polynomials. And I'm going to then pick out the piece of it that is above the x-axis. So, let's get down to business. How do we graph a rational function? Well, I would like to know what is its domain. First off, I know that x cannot be 0, so that's definitely not going to be part of my solution. Alright, now I can look at intercepts, the y-intercept. If x is 0, well, we have a problem. We just said that x isn't allowed to be 0. So this function actually does not have a y-intercept. That's one of the few functions that we've seen that doesn't have one, but it does happen. Now, if we want to find the x-intercept, we can set our function equal to 0 and try to solve for x. So I might do this by multiplying both sides by x, and that'll clear my fractions. Now on the left I have 0 times x, so that's just 0, and on the right I have my numerator, x plus 1. So we see, if I subtract 1 from both sides, that x equals negative 1. That's our x-intercept, negative 1, 0. And finally, we might want to talk about asymptotes. This is a rational function, so it could have some. And I guess we'll start with the vertical asymptote, if it has a vertical asymptote. So we take our denominator and set that equal to 0. And we're pretty much done. That is our vertical asymptote. We're talking about the y-axis. Now, as for a horizontal asymptote, I look at my function, x plus 1 over x, and I notice the degrees of numerator and denominator are the same. Okay, so this one we have to do a little bit of work. I would say my horizontal asymptote exists, and it is the quotient of the coefficients of the leading terms, which are both 1. So y equals 1 is my horizontal asymptote. So I'm going to sketch this. It's not going to be the most amazing drawing, but it doesn't really need to be for our purposes. I have a horizontal asymptote at 1, and a vertical asymptote along the y-axis. So I'll kind of indicate that that is extending outward, or up and down. Our x-intercept at negative 1, 0, and we have no y-intercept to speak of. So the behavior on the left is trapped by the vertical asymptote. Now, we haven't decided if this function crosses its horizontal asymptote. Let's do that really quickly. Set off a little bit of space over here. So remember, to do that, I'm going to set my function, x plus 1 over x, equal to the value of the horizontal asymptote, which is 1. So if I cross-multiply, if I multiply both sides by x, I get x plus 1 equals x. And if I subtract an x from both sides, I see that this implies that 1 equals 0, which is obviously nonsense. That is false, so that is false, which means that our function never crosses its horizontal asymptote, and we can continue our trajectory. Now, I would like to get a little more information about what's happening to the right of our vertical asymptote. So if I plug in x equals 1, what do I get for y? Well, my function is x plus 1 over x. So that would be 2 over 1. That would give us 2. So when x is 1, y is 2. And we are above the horizontal asymptote. Now we're stuck above it, and we're stuck eventually approaching it. So our graph would look something like this. And now I get to pick out which parts of it I like. I like stuff that is above the x-axis strictly, not on it, not below it, but above it. And this piece that's above the horizontal asymptote certainly satisfies. So everything from 0 to infinity, not including 0, remember we can't even plug 0 in, so it definitely isn't part of the solution. And then this little piece over here that is stuck between the horizontal asymptote and the horizontal axis is also positive. It's also above the axis, so we would say negative infinity up to -1. That's where we crossed. So our solution, just to write it all out, negative infinity to -1, union 0 to infinity. Now it's worth noting that my parentheses in the left-hand set are because we don't include that x value because it doesn't satisfy the inequality. The parentheses in the right-hand interval or the parenthesis at 0, is because 0 is not even in the domain of the function. We can't plug it in, so it is absolutely not a solution. It will not even make our function have a defined value. So that is our solution interval, and we'll see another one of those in the next video.